Good morning. So this week you're going to have a digital representation of your teacher explaining the notes. So a couple things here. Since this is on a video, my suggestion would be to watch it a couple of times. Maybe watch it once all the way through and then watch it again to take notes, because I'm going over the notes. You want to write this stuff down. Second of all, if I'm going too fast, then feel free to pause it and catch up, because that's one of the things that you can do. It's really hard to get me to pause in class, but you'll have no trouble hitting the pause button for the video. Okay, so today we're going to be working with geometric sequences and series, which is not a whole lot different from the arithmetic, but as the way it's been the rest of the year, multiplying and dividing is always easier than adding and subtracting, and the geometric sequences are no different. So the difference between the arithmetic sequences and geometric sequences is that with arithmetic sequences you had to add or subtract the common difference to each term to get the next term. For geometric sequences, you're multiplying and dividing, and instead of calling it a difference, we call it a ratio. So geometric sequences are come by multiplying. You're going to multiply or divide each consecutive term, so that means in order, each consecutive term by a common ratio. Common means the same. Okay, so if we take a look at the A sub n rule, we have a different A sub n rule, which has absolutely nothing with adding and subtracting and everything to do with multiplying and dividing. So just like before, A sub 1 is going to be our first term. Sometimes it'll be given to you, sometimes you'll have to find it. And R is our common ratio. Okay, just like the arithmetic sequences, you need a couple of things to write the A sub n rule. So with the geometric one, you are going to need the first term, just like before, and instead of the common difference, you are going to need the common ratio. So A sub 1 and R. And in order to find R, we're going to divide the second term by the first term. And this is kind of like the difference, finding the common difference, because with that one, we subtracted A sub 2 minus A sub 1. For this one, we're dividing A sub 2 divided by A sub 1. So we're still kind of going in a backwards order. Okay, let's take a look at writing rules. We're going to be using this one up here that we just outlined. Okay, so now we're given a sequence, 3, 15, 75, and 375. And then it goes on forever and ever. We have two tasks. We have to write the rule, and then we're going to use that rule to find another term, which is A sub 8. Okay, so first of all, we need A sub 1. A sub 1 is the first term. First term is going to be 3. Next, we need the ratio, and the ratio is going to be the second term divided by the first. So we're looking at 15 divided by 3, which is equal to 5. Okay, so now we have our first term and we have our common ratio. Now all we have to do is plug them in. So A sub n is going to be equal to our first term, which is 3, times our ratio, which is 5, to the n minus 1 power. Voila! And you don't have to simplify anything. It's already simplified. So see, this is much easier than what the arithmetic sequences and series were. Okay, now that was our first task. Our second task was to find A sub 8. So we're going to say A sub 8 is equal to, and then our first term, which is 3, times our ratio, which is 5, times n minus 1. Okay, in this case, the term number is 8, so it's going to be 8 minus 1. So we say 7. Okay, so now when we plug this into a calculator, we're going to say 5 to the 7th power, use that caret key, and that's equal to 78,125. And we're going to multiply that by 3. And we get 234,375. Okay, so A sub 8 is equal to 234,375. And we have our term, which is a very large term. Okay, let's take a look at example 2. And for this one, we're not given quite as much. So we have our ratio, which is 2, and we have a sub 6, which is negative 96. Okay, we don't have a sub 1. So first of all, we need to find a sub 1. So we're going to plug everything in except for a sub 1. So it kind of looks like this. So we'll say a sub 6 is equal to a sub 1, which we don't have, times our ratio, which we do have. Ratio is 2, times the to the n minus 1 power. Okay, since we're using a sub 6, n is 6. So 6 minus 1 is 5. Okay, we know what a sub 6 is, so let's put that in. Negative 96 equals a sub 1 times, and 2 to the 5th is 32. Okay, so a sub 1 times 32 equals negative 96, so let's just divide both sides by 32. And we're going to get an a sub 1 value of negative 3. Okay, so now we have our ratio, we have our a sub 1, and we can set up our formula. So a sub n is equal to negative 3 times 2 to the n minus 1. And that's our a sub n rule. Okay, so if you're missing one thing of the two things that you need, plug everything in and solve for the one that you're missing. Okay, now we still want to use this because our second task was to find a sub 8. So we're going to say a sub 8 is equal to negative 3 times 2 to the n minus 1. Or in this case, a sub 8 equals 3 times 2, n minus 1. In this case, 8 minus 1 is going to be 7. Okay, so we get the calculators back out. And we are looking at 2 to the 7th, which equals 128, times, I don't know why I put a minus, okay, times negative 3, which is negative 384. Okay, negative 384. And that is going to be the 8th term in our sequence. All right, now let's take a look at an example where we are given neither a sub 1 or the ratio. Okay, and I kind of showed you this before. So what we're going to do is a very visual way of doing this. We have a sub 2 and a sub 4, so let's go ahead and set that up. Okay, so 1, 2, 3, 4. A sub 1, we don't know. A sub 2 is negative 12. A sub 3, we don't know. A sub 4 is negative 3. Okay, so we're going to do what we did before. We're going to let this be a sub 1, so that means this is a sub 2 and this is a sub 3. It's a substitution kind of thing. Okay, so now we want the ratio. We kind of have a sub 1, so we're going to use this as our a sub 1. We're going to use this as a sub 3 and plug in what we know in order to find the ratio. Okay, so we're going to say a sub 3 equals a sub 1 times our ratio, and since we're using the third term, then we're going to say 3 minus 1, which is 2. Okay, now let's go ahead and plug our numbers in. So a sub 3 is negative 3, and a sub 1 is negative 12 times r squared. Okay, so we want to get the r squared by itself, so let's divide off the negative 12 from both sides. When we divide off negative 12 from both sides, those cancel, and we're left with r squared on the right. On the left, negative 3 divided by negative 12 is positive 1/4. Okay, so take the square root of 1/4, which would be the square root of 1 over the square root of 4, and we're going to get r is equal to 1/2. And I know that's kind of positive and negative 1/2, but we're not going to worry about that right now. Okay, so now we have our ratio. Let's go back to our original visual here. Okay, so this isn't really a sub 1. This is really a sub 2. This is a sub 1. So if our ratio is 1/2, then half of negative 12 is negative 6. And half of negative 6 is negative 3. So that rule is going to work. Okay, so if we're multiplying by 1/2 to go forward, then we're going to multiply by the reciprocal going backward, so we're going to multiply by 2. So if we multiply negative 12 by 2, we're going to get negative 24. This is going to be our a sub 1. Okay, so now we have our ratio, we have our a sub 1, so we can set up our a sub n rule. So we're looking at a sub n is equal to negative 24 times ratio of 1/2, and I'm putting this in parentheses to the n minus 1, because otherwise this n minus 1 only affects the 1, and we want it to affect the whole 1/2. Okay, so I have my a sub n rule, and we want to find a sub 8. Okay, so we can do this two ways, and I'm going to show you both of them. Since we went to all the trouble of writing this, let's go ahead and plug in a sub 8 and find out what it is. Okay, so we're looking at negative 24 times 1/2 to the 8 minus 1 is 7, so to the 7th. Okay, so looking at it from here, and I always do this first so it doesn't automatically do 24 times 1/2 to the 7th power and give me an answer I don't want. So let's see, we're going to do in parentheses 1 divided by 2 to the 7th power, so hit your caret key and 7, and I'm going to hit equals. And now I'm going to multiply that times negative 24. So times negative 24. Okay, I still have a really ugly decimal here. So I'm going to hit my math button. You can hit your ABC button. And I'm going to press 1 for fraction. And I get negative 3/16. Okay, so the answer then for a sub 8 is negative 3/16. Okay, I told you I was going to show you another way to do this. And it's a little bit more straightforward, although it might be a little bit more work. Okay, so we have 1, 2, 3, 4. A sub 4 was negative 3. Okay, so 3, where was I? A sub 4, 5, 6, 7, and we want a sub 8. Okay, so we're going to multiply negative 3 by 1/2. Negative 3 times 1/2 is negative 3/2. Okay, now we'll multiply this times 1/2. We're just multiplying the bottoms. We're doubling it each time. So negative 3 times 1 is negative 3. 2 times 2 is 4. Okay, now we're going to multiply this times 1/2. So negative 3 times 1 is negative 3. 4 times 2 is 8. And then one more time. Negative 3 times 1 is negative 3. 8 times 2 is 16. And we got the same thing that we did right there. Now, which one was easier? Probably this one. You know, if you're pretty good with the calculator, which one was more straightforward? Probably this one. So it's entirely up to you which one you use. It'll probably depend a lot on how far away this number is to what you found. Okay, that's enough of sequences and writing rules. Let's take a look at our geometric series formula. Okay, so we've got a lot of stuff in here, but you probably recognize all of it. I will go ahead and define it for you. You know what, though? Before I do that, I really need to finish this up. Okay, there's our other part. All right, so taking a look at our summation notation, we've got the sum of n terms. This, of course, is the first term. And that's our ratio, common ratio. And this is our common ratio. Only difference between them is that this one is going to be to the power of how many terms you want, not n minus 1 this time, just n. So if we want the sum of 8 terms, then this is going to be r to the 8th. And then we're making a giant fraction that we're going to multiply times the first term. Okay, so let's see how this works. We have summation notation starting at the first term going through the 8th term. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, that works out good. It's 8 terms. So we're going to, we could go ahead and figure out what all of these are. Okay, so right here, this is going to be your first term. Okay, so this is a little bit different than what the S sub n formula for arithmetic sequences, and that's going to be your common ratio. And if we didn't know that, we could go ahead and plug it in for our first term, because we need our first term and our ratio. So if we go ahead and plug that in, we would get 6 times negative 2 to the 1 minus 1. Okay, 1 minus 1 is 0. Negative 2 to the 0 is 1. So 6 times 1 is going to be 6. So anytime you're looking at summation notation, if it's geometric, this is going to be your first term, and this is going to be your common ratio. Okay, which makes it, by the way, really easy to write summation, or to write an a sub n rule from. Okay, so we're adding this up though, so we're going to use this formula here. So we need our a sub 1 and our ratio. So a sub 1 is going to be equal to 6, and our common ratio is going to be equal to negative 2. Okay, let's go ahead and plug this in. We want summation of 8 terms. So we're going to say S sub 8 is equal to a sub 1, which is 6, times 1 minus, and then this is negative 2 to the nth power, okay? And n is going to be 8, so we're going to say to the 8th power. And all of that is over 1 minus a negative 2. All right, I like to simplify this a little bit at a time. So this is 1 minus a minus 2. So 1 plus 2. So all of this is going to be 3. All right, then over here, negative 2 to the 8th power. Okay, and I know you can probably do this without the calculator, but let's just put it in anyway to be safe rather than sorry. Okay, so we're going to say in parentheses, negative 2, and then raise it to the 8th power, and we're going to get positive 256. Okay, so this is 256. Okay, so I did not do anything with this. I only used this negative right here. So what we have is 6 times 1 minus 256 over 3. Okay, so I can do a couple things here in order to make this easier. First of all, I'm going to get rid of my denominator. If I divide this by 3, I get 1. If I divide this by 3, I get 2. Okay, so that looks a little better already. And then 1 minus 256 is negative 255. Okay, so my problem now is 2 times negative 255. So 2 times negative 255. And that's going to be equal to negative 510. So S sub 8 is equal to negative 510. All calculator work, and I don't think you'll have any trouble with it. This is Tuesday. Remember, you have a quiz on Friday. Okay? Then I will see you tomorrow. See ya.